Statement we wrote, ma'am.
Next property, put the heading differentiation in S-domain property. So properties we were discussing. Differentiation in S-domain. Let us see the proof also. Differentiation in S-domain. What was the statement? Just a statement we completed in the previous lecture. So the differentiation in S-domain property states that if x of t Laplace transform is x of s, then t into x of t is its Laplace transform minus d by ds into x of s. Okay. Proof. Let us see the proof. So consider x of s expression, that is Laplace transform of the signal x of t. And then what is the formula we have? Minus infinity to infinity signal multiplied with kernel. But what we have here in the proof, d by ds of x of s is there, right? So apply differentiation on both the sides with respect to s, because what we have on right hand side minus d by ds of x of s is there, isn't it? So let us see start the procedure proof using that minus d by ds. Apply differentiation on both the sides with respect to s. That means d by ds of x of s equal to, now differentiation of this total integration with respect to s. But when we are doing differentiation with respect to s, except s, whatever terms are there, they all are treated as constant, isn't it? They all are treated as constants. So in differentiation of this total expression means that particular differentiation is applicable only for this function d by ds of e power minus st dt. Okay. Differentiation of this total expression means it is valid, that a differentiation is valid only for e power minus st. Now solve this. Try to prove. Minus infinity to infinity x of t. Differentiation of this one, when we are doing differentiation with respect to s, means except s remaining terms. What are the remaining terms? Minus st, differentiation is minus t. Exponential differentiation is again exponential function dt. Okay. Next, arrangement of terms. So let us continue the steps. D by ds of x of s equal to minus infinity to infinity minus t into x of t into e power minus st dt. Now see here, this is of the form signal multiplied with kernel, Laplace transform kernel, right? Signal multiplied with Laplace transform kernel. But what is there in place of signal? Minus t into x of t. So minus t into x of t, what is its Laplace transform? D by ds of x of s. Okay. Or t into x of t, what is its Laplace transform? Minus d by ds of x of s. T into x of t, Laplace transform is minus d by ds of x of s. Hence proved. Okay. Hence proved. Note. So what we got here? T into x of t. What is its Laplace transform? Minus d by ds of x of s. Similarly, in general, t power n into x of t, Laplace transform is going to be minus 1 whole power n into d power n into x of s by ds power n. Okay, this is an important formula. We use it in solving the differential equations and finding transfer function, inverse Laplace transform. Okay, application is more this property application. Okay, system related problems. So t power n into x of t, Laplace transform is -1 whole power n into d power n into x of s by ds power n. Okay. Next property. Conjugation and conjugation property. Statement, conjugation property statement. If x of t Laplace transform is x of s, then x star of t Laplace transform is capital X star of s star. Okay, x star of t Laplace transform is x star of s star. Let us see the proof. Okay, so consider left hand side. What we have left hand side? Laplace transform of x star of t. So general definition, standard definition we use signal multiplied with kernel. But in place of signal, what we have? X star of t. Signal. What is the kernel for Laplace transform? E power minus st dt, right? E power minus st dt. So now I would like to write this in conjugation as whole conjugation of this integration. For that, we need to arrange the terms minus infinity to infinity, signal multiplied with kernel. So see here in this proof, x of t into e power minus, in place of s I am writing it as s star t dt. So Laplace transform of x star of t as it is. Just observe the change. Minus infinity to infinity, x of t into e power minus, in place of s I have written s star of t dt. Whole star is there. Okay, signal multiplied with kernel, just arrangement of terms. Now see here, this is of the form signal multiplied with kernel, which is nothing but Laplace transform formula kernel. But in place of s, what we have? S star is there. So this is nothing but x of s star whole star. So we can write this as x star of s star, isn't it? Hence proved. Hence proved. Okay. Consider left hand side x star of t, signal multiplied with kernel. Now let us arrange this conjugation to whole integration. So let us apply this integration. That for that we need to arrange the terms. That means x of t into e power minus s star of. So it's nothing but x star, s star whole star is s only. That means we know this. A star whole star is a only. So for that, based on this, I have written s star. Again, star means that will be remains as minus s. So this is in the form x of t into e power minus st dt. But in place of s, s star is there. So it is x of s star whole star, which is a statement of conjugation property. Hence proved. Okay, this is a conjugation property and proof. So let us see the convolution property. For remaining all the properties, simply statement I will be giving. Okay, only for convolution we see the proof. For remaining all, just a statement. Remaining all, we are left with only two more properties. Just statements are sufficient for those properties. Put the heading time convolution property. Time convolution property. Statement. The time convolution property states that You are very familiar with the time convolution property in Fourier transform itself, isn't it? So based on that, you can write the statement. If x1 of t, Laplace transform is x1 of s, which type transform mentioned here, and x2 of t, Laplace transform is x2 of s, then time convolution property states that x1 of t convolution x2 of t Laplace transform is x1 of s into x2 of s. Okay, let us see the proof now. Proof. So here we are going to use the definition of convolution. Okay. x1 of t convolution x2 of t. What is the formula we have for convolution? Minus infinity to infinity x1 of tau into x2 of t minus tau d tau. Otherwise, the same formula can also be written as first signal may be shifted x1 of t minus tau into x2 of tau d tau. Okay. Now consider Laplace transform of this left hand side. Consider Laplace transform of x1 of t convolution x2 of t. What is the formula we have? Minus infinity to infinity x1 of tau into x2 of t minus tau d tau, isn't it? This is a definition of convolution. Laplace transform. This is nothing but convolution definition. Signal multiplied with kernel to find the Laplace transform. Okay. x1 of t convolution x2 of t. In place of signal, directly I have written the definition. x1 of t convolution x2 of t. Done? Okay. Same as Fourier transform convolution property proof. So here again arrangement of interchange of orders and all. Okay. Let me write the same step once again. Minus infinity to two integrations will be there. x1 of tau into x2 of t minus tau d tau into e power minus st dt. This total thing is formula for x1 of t convolution x2 of t. Okay, up to here, up to this signal multiplied with kernel. Here nothing but Laplace transform of x1 of t convolution x2 of t. Please correct it. Previously I didn't include that integration, double integration, because we are finding Laplace transform signal multiplied with kernel. Signal is convolution between two signals. So convolution definition I have written here. Okay. So here like arrangement of terms and all, interchanging the order and all. So first minus infinity to infinity, whatever first term is there, let us write it outside, single x1 of tau, then minus infinity to infinity x2 of t minus tau, okay, then e power minus st d tau dt, interchanging the order of integration. That's it. Next, let t minus tau equal to some other time variable p, small p. Okay. Minus infinity to infinity x1 of tau, limits will remain same. x2 of what I have to write here? P e power minus in place of t, because in this expression I am assuming t minus tau as p. In place of t, what I have to write? P plus tau, and d tau or dt will converted into dp, then d tau. Okay. Here interchanging the order of integration means first we have to write dt, then d tau. Okay, because x1 of tau is here. Final integration, first order of integration is with respect to t, then d tau. Please change it. Sorry, correct it. After that, let t minus tau equal to p, then x2 of p into e power minus s, in place of t, p plus tau. Because from this, what is t? P plus tau. So I have substituted here. and in dt is nothing but tau is constant, dp and t tau. Okay. So next. Minus infinity to infinity x1 of tau minus infinity to infinity x2 of p e power minus sp e power minus s tau dp, important Laplace transform concept. Okay. So when the integration is with respect to p means tau is treated as constant, isn't it? So here e power minus s tau you can write here because first order integration is with respect to p. Minus infinity to infinity x1 of tau into e power minus s tau minus infinity to infinity x2 of p into e power minus sp into dp into d tau. Okay. Now tell me what is this? What is this? This is nothing but x2 of s because signal multiplied with kernel e power minus st dt form is there, isn't it? So this is nothing but Laplace transform of the second signal x2 of t. Same as Fourier transform convolution property proof, important in case of Fourier transform as well as here. So minus infinity to infinity x1 of tau e power minus s tau. What I have to write here? x2 of s d tau. Integration is with respect to tau. So let us write x2 of s outside. Minus infinity to infinity x1 of tau e power minus s tau d tau. What about this? This is x1 of s. So finally what we get? x2 of s into x1 of s. And what is there here? Laplace transform of x1 of t convolution x2 of t. Clear? So hence proved. This is a proof for convolution property, time convolution property. Okay, same as Fourier transform, but in place of omega here we have s variable. Okay. Shall I go for next property? Statement, simply statement for next property. Next property, convolution in S domain property. Convolution in S domain or multiplication in time domain. Reverse to that previous property. Statement, if x1 of t Laplace transform is x1 of s and x2 of t Laplace transform is x2 of s, then time convolution in S domain or multiplication in time domain property states that x1 of t into x2 of t. What is its Laplace transform? x1 of s convolution x2 of s, but there 1 by 2 pi was there. Here 1 by 2 pi j. So in any standard textbook you can find the proof for this. So here mostly we use it in finding inverse Laplace transforms or system problems only, but applicability is very limited compared to that of convolution in time domain. Proof is also same as that of Fourier transform. Here also we use inverse Laplace transform formula in the proof, but as of now just a statement is sufficient related to our syllabus and expected questions. Okay, this is a statement of convolution in S domain property. Okay, next one more property statement which I didn't cover. Hope you have copied. Next, last property, time integration. Time integration property. Write down. Time integration property statement. If x of t Laplace transform is x of s, then minus infinity to t, for causal signals it will be up to t. When t is upper limit, here signal is replaced with a dummy variable tau. Its Laplace transform is x of s by s, x of s by s plus minus infinity to 0 x of tau by s d tau. Okay. So if initial conditions are assumed to be 0 means, minus infinity to t x of tau d tau, in general the formula is given as 1 by s into x of s. In differentiation property, it was like a s into x of s, isn't it? If it is dx of t by dt means s into x of s was there. Integration means 1 by s we will get. Integration property 1 by s. Okay. Statement is sufficient. This statement you have to remember. Minus infinity to t x of tau d tau Laplace transform is 1 by s into x of s. So this is the last property. So with this, we have completed Laplace transform properties. Let us see some more problems, how to use these properties and all. Okay. If initial conditions are assumed to be 0 here, if only causal signals are considered, then assume it to be 0, as well as causal signals, which exist only for t greater than 0. Okay. Problems. Try to solve this. Find Laplace transform of the signal x of t equal to cos omega t into u of t. Cos omega t into u of t. So here we use linearity property as well as shifting property. Okay. Linearity as well as shifting property. Try to solve this. So in general, cos omega t, how do we write cos omega t? E power j omega t plus e power minus j omega t by 2. Okay. So into u of t is there. So cos omega t into u of t. It's nothing but 1 by 2 into e power j omega t plus e power minus j omega t into u of t. Apply Laplace transform on both the sides. Apply Laplace transform on both the sides. Laplace transform of cos omega t into u of t equal to half is constant. So it's nothing but half into Laplace transform of this total term e power j omega t plus e power minus j omega t into u of t. Okay. Half into a plus b form is there. Set it. Just linearity property. It's nothing but Laplace transform of, expand these two terms, e power j omega t into u of t plus e power minus j omega t into u of t. Okay. Try to solve that. Use linearity as well as shifting property. So it's equal to 1 by 2 into Laplace transform of e power j omega t into u of t, which is the first signal, plus Laplace transform of second signal, e power minus j omega t into u of t. Okay. Now, what is that standard formula we use here? Standard pair e power minus at into u of t. What is its Laplace transform? We have 1 by s plus a, where real part of s is greater than minus a. How do we got this? How did we get this ROC, region of convergence? ROC is nothing but real part of s only. So whenever denominator is greater than 0, s is greater than minus a. Here imaginary part is not there. So this minus a corresponding to real part of s only. So our ROC is real part of s. What is the restriction? Minus a. Like that, we got this ROC, right? In the same manner, real part of s, only that is the ROC which we need in finding Laplace transforms as well as inverse Laplace transform. We want only real part of s values. We don't bother about imaginary values, okay? So now use this in the first exponent in place of j omega minus a. In place of minus a, j omega is there. Here, in place of a, j omega is there. So let us apply this. 1 by 2 into, now what is the Laplace transform of this? 1 by s plus a. Minus is there, plus we got. Here, minus of minus j omega t. So I write this as s minus j omega. Because in place of a, j omega is there. Here minus a is there, is here plus j omega is there. So we get it as s minus j omega. Plus what about here? S plus j omega. And the restriction here is, for example, if you see this, s minus j omega greater than 0 means s is greater than j omega. What about real part of s? Here, right hand side, only imaginary part is there. Real part is 0. So the ROC is related to real part of s only. ROC is nothing but real part of s. So real part of s is greater than 0. That is our ROC here. Real part of s is greater than 0. Because here only imaginary values are there. Real parts are not there means zeros. We consider them as 0. Now take LCM and solve this. 1 by 2 into a plus b into a minus b. Denominator LCM. A square minus b square. In place of b, j omega is there. Plus j omega whole square. A, b. J omega is a b. And what about numerator? S plus j omega plus s minus j omega. It will be 2s. Then what is the Laplace transform? 1 by s by s square plus omega square, where ROC is real part of s greater than 0. This is a corresponding Laplace transform for cos omega t function. Important. Find Laplace transform for sin omega t, cos omega t. Okay. J square value is minus 1 here. Minus into minus will change to plus. Similarly, try to solve for x of t equal to sin omega t into u of t. Find Laplace transform for x of t equal to sin omega t into u of t. So what is the Laplace transform for cos omega t into u of t? S by s square plus omega square, where real part of s is greater than 0. So next, try to find for sin omega t. Important problem. This is also find same procedure. Find Laplace transform for the signal x of t equal to sin omega t into u of t. Okay. Proof. Sin omega t, how do we write? E power j omega t minus e power minus j omega t whole divided by 2j will be there in the denominator. Okay. If you don't remember these exponential related relations, means we cannot derive any transform for sinusoidal functions, sine as well as cos. Okay. Mostly sinusoidal responses, transient analysis are important. So while studying steady state analysis and transient responses in control system applications, we need all these transformation pairs because these are given as input for those kind of first order and second order systems. Okay, so definitely these formulas are applicable. Application will be there in control system and later on next semester subjects. Okay. Now apply Laplace transform on both the sides. Sine omega t into u of t is there in the problem. 1 by 2j into e power j omega t minus e power minus j omega t into u of t. Try to solve this. Laplace transform of sine omega t into u of t. 1 by 2j is constant. It's nothing but Laplace transform of this function e power j omega t minus e power minus j omega t into u of t. Okay. Let us split this 1 by 2j into Laplace transform of first term, linearity property we use here, minus Laplace transform of second term into u of t. Okay. Continue this 1 by 2j. Now what is the Laplace transform of this function? Just now we have solved s minus j omega minus what is the Laplace transform of this function? S plus j omega. And real part of s is definitely obviously greater than 0. The numerator what we get? S plus j omega minus s plus j omega. So in the numerator we are going to get it as 2j omega whole divided by a square minus b square. In place of b square, j omega square. So j will get cancelled, 2 will also get cancelled. Then what about function s square plus omega square, where real part of s is greater than 0. This is the corresponding Laplace transform pair for sine function. Important, these two are repeated question. Find Laplace transform for sine and cos functions using linearity and shifting property. Okay. Note, cos omega t into u of t. What is its Laplace transform? S by s square plus omega square, where real part of s is greater than 0. Important. Sine omega t into u of t. What is its Laplace transform? Omega by s square plus omega square, where real part of s is again greater than 0. Okay. Now based on this, next example, find Laplace transform of the signal. Based on this, find Laplace transform of the signal x of t equal to e power minus at into cos omega t into u of t. Now which property we have to use here? Please try to analyze and try to solve this problem. Which property we have to use here? E power minus at into x of t. E power minus at into cos omega t into u of t is there. Important, this problem is also repeated. Properties application, all these properties are, all these problems are. See here, by just observing the signal itself, you have to analyze that this is of the form. If x of t Laplace transform is x of s, then e power minus at into x of t Laplace transform. Refer the properties. What is its Laplace transform? X of s plus a, isn't it? If x of t Laplace transform is x of s, means e power minus at x of t Laplace transform is capital X of s plus a. So e power minus at is there. Now this total thing, take it as a reference, means this is treated as x of t. We know this corresponding Laplace transform. This is our x of s. E power minus at into signal Laplace transform is s plus a, means s has to be replaced with s plus a here. Like that, application is important, properties applications. Okay. So these are this is one example where we use this shifting property and all. Like this, solving problems is important. More and more problems will be there in next related subjects and topics next semester onwards. Okay. Here also, this is also repeated question. E power minus at into cos omega t into u of t, which is application of this particular property. Try to solve this. Okay. (24 participants).